Good morning. Today we are going to deal with role of synchronous generator in ancillary system services in the restructured power system. So why this synchronous generators is still a matter in this ancillary services in the sense. For example, if you take with the high penetration of renewable and inverter-based resources, these synchronous generators remains the cornerstone of this grid stability because it provides the natural physical support that the electronics alone can't fully replace. That power electronics devices or that alone can't fully replace. So this synchronous generator not only produces the uh, real power but also provide essential control services that keeps the grid stable. So evolution from mandatory obligation to market based service. So why in restructured power system it is important. So if you take the traditional power system, synchronous generator automatically provide the stability services. No separate payment is needed in the traditional vertically integrated market. So bundled with the energy protection that we all know. So if you take like restructured power system, services are unbundled. Okay, services are unbundled. That means it is segregated into each utility. The services are segregated to all each utility. So synchronous generators are paid separately for each services. Am I right? So if you take like synchronous generators in the restructured power system, it is a separate ancillary services. So they are paid separately for each services to compete with the storage and as well as demand response, inverter based resources and all. So, in restructured power system, this synchronous generators as ancillary services, it is a separate ancillary services that is paid for their services. So if you take like traditional system, ancillary services, there is a mandatory thing is there. So in traditional system, it is mandatory. Okay, but in restructured system, everything is based on the market based. Okay, so market based generating companies or market based transmission companies, whatever they decided, based on that, they will provide the ancillary service. But if you take like traditional system, these ancillary services are mandatory. If you take like compensation embedded in the tariff itself for a traditional system, but restructured per system, separate payment you need to make because it is a open access system. So everything is clearly open access. So separate payment has to be made. So competition in the traditional system is no. But if you take in restructured power system, competition is higher. So if you take like a service operator role in traditional system, it's just an operator. But in restructured power system, it is a market procurer. Okay, so that is the main role of service operator role. Next comes the ancillary services provided by the synchronous generator. Say, for example, if you take like frequency regulation, role of the synchronous generators. So, if you take the role, governance, that governance will be there. That is automatically responding to this frequency deviation. So, governance, so whatever the frequency deviation happening, so feedback is given to the governance such that in turn it increases the speed of the synchronous generator. That means automatic generation control adjusts the output of the generator continuously based on the feedback. So why this synchronous generators are effective? So effective because physical inertia smooths the frequency changes. Okay, so inertia is given by J. Okay, so E is equal to kinetic energy E is equal to half J into omega square. So based on that, the physical inertia smooths the frequency changes, and also proven reliable technology that is there. So if you take like a response feature with respect to response for the synchronous generator frequency regulation. So how much time it will take is from seconds to minutes. Within that time, this synchronous generators will respond within some seconds to minutes. So control, if you take like governor plus automatic generation control, and accuracy is also higher accuracy is there. So if you take like market regulation up and down will be there. So based on the frequency regulation. So synchronous generators provide both the primary and secondary frequency control naturally. Okay, so it provides the both the primary control and as well as secondary frequency control naturally. So that is also there. So and if you take like operating reserve, so first if you take like spinning reserve, generator is online but not partially loaded. Online generators will be there, but not partially loaded. Okay, spinning reserve already I discussed in detail. So it is a backup generator. So that is also will be running. Okay, so that is also in operation. So if any fault happens, suddenly this synchronous spinning reserve generators will come into the online. So generator is online, but not but partially loaded, only partially loaded. Okay, can respond within less than 10 seconds. Okay, suddenly the spinning reserve will be operating and maintaining the reliability of the system. So if you take like a status, the spinning reserve is synchronized always in the system, in the restructured power system, but extra you need to pay. Response is very fast, less than 10 seconds. Cost, opportunity cost, based on the opportunity cost, reliability is very high. And if you take like a supplemental reserve, it is like fast starting synchronous generators. For example, if you take like gas generator, fast starting, hydro generators also fast starting. Okay, so available within the minutes. So if you want to switch on the hydro generators, just within some minutes you can on, and also gas generator immediately with some minutes you can on. So these are the supplemental reserve. So if you take like status of this supplemental reserve is offline, it is not online, offline. So it will take some minutes. You need to wait for some time. Response it is in minutes. Cost is somewhat lower compared to spinning reserve. So usage is replacing the this spinning reserve. So comparison, if you take like synchronization, spinning reserve, yes. Supplemental, no, not synchronized in the system as like a spinning reserve. And the speed, if you take like a spinning reserve is fast, supplemental is moderate. It will take some minutes of time. But in spinning reserve, it takes some less than seconds. Okay, less than 10 seconds like that. So cost is higher for spinning reserve because always it is synchronized. No, it is running and partially loaded. But in supplemental, lower. So whenever they are using, you need to pay like that. So when compared to spinning reserve, it is lower. And if you take like a voltage control, reactive power support, how the synchronous generator controls the voltage by using the automatic voltage regulator. That means AVR. Okay, so adjust the excitation based on the feedback to supply or observe the MVR. That means reactive power. Okay, whenever if you want to observe the reactive power, whenever you need to supply the reactive power based on the feedback. So reactive power support is local and critical for voltage stability. So if you take like opportunity cost issue, so more MVR output. Okay, the next effect is less megawatt capacity. Okay, so if more reactive power, then less power active power capability. Curtailment, if you take like loss of energy revenue also will be there. So since hence synchronous generators are paid for reactive power in the restructured power market. Okay, so only for reactive power the synchronous generators are paid. Okay, so if you take like black start capability, already we have seen in detail about the black start capability. What is the role of the synchronous generator black black start capability? Since self starter by using the diesel or battery systems. Okay, synchronous generators is acting as self start in the black start capability. Next, which establish the voltage and frequency in the system and the cranks larger non-black start units. So self start for the synchronous generated black start is yes. Grid formatting also yes. Reliability is very high. Contracted type is long term. Some bilateral contract model. If you go for bilateral contract model, long term we can plan for this black start services. Next comes the grid inertia. So grid inertia also one of the important unique advantage. So what is meant by inertia? If you so take like stored kinetic energy in rotating mass, E is equal to half J into omega square. Where J is what? J is nothing but this inertia. Okay, J is nothing but inertia. So if you take like what is omega is nothing but angular frequency. Okay, so angular frequency, so which is measured in kilogram meter square. Okay, so this inertia also matters, so it resists the sudden frequency changes. So why inertia is valuable means if a renewable energy system reduce the system inertia. Okay, so faster frequency decline will be there. That means ROCOA, faster frequency decline will be there. Okay, in the system. So what is the main feature of this physical inertia is for synchronous generator, the inertia will be there. Okay, generally inertia due to the kinetic energy, that the inertia will be there. Next, the rate of change of frequency damping. Okay, rate of change of frequency damping also is excellent in this synchronous generator. So market value is increasing. Okay, for this grid inertia. Okay, so inertia is not dispatch; it is inheritance. So you can't dispatch the inertia, and also it inheritance, and also faster frequency decline also will be there. Okay, so renewable system will reduce the system inertia. Okay, that is also notable point. So management of the synchronous generator ancillary service in restructured power system. So, okay, if you take like regulation, in spot market, the regulation is maintained. Next, if you take like reserves, the spot and the forward markets, they are using this synchronous generators reserve. Regulation synchronous generators regulation in spot market. Next, synchronous generators black start in long term contracts model. Okay, synchronous generator for reactive power control in nodal or locational markets. That is also possible. So if you take like co-optimization, so energy plus ancillary services that cleared together, which minimizes the total system cost also, and avoids the inefficient dispatch. Okay, example, if you take a generator may reduce the megawatt output to earn higher reserve. Okay, so that is also one of the examples. So a generator may reduce the megawatt output to earn higher reserve revenue, because for automatically, say for example, generator reduces the megawatt output, automatically reserve revenue will increase. That is also possible. Sometimes statically, some companies, generator companies will use, but due to the bilateral contracts and all, that the price will not increase. Okay, but sometimes wisely they may do this kind of activities also in the market. Next comes the pricing mechanisms. So, based on the cost-based synchronous, based on cost-based regulated recovery will be there. If you take like bid-based competitive pricing is there. Performance-based speed and accuracy will be rewarded in the restructured power market. So, if you take like secondary reserve ancillary service, that means SRAS, and the tertiary reserve ancillary services. These are called advanced reserve products. This is also in the research power market. So based on bid based, performance based, and that we have seen in detail in our previous classes how the bidding is happening. Everything we have seen detailed in the previous classes. Next, if you take like service unbundling, in the vertically integrated, in the restructured part of it, the services are not unbundling. Okay, so separate like generation companies, one entity. distribution company one entity, transmission company one entity, ancillary service one entity, like. So energy also is not equivalent to this ancillary services. Okay, so same generators can sell energy in a vertically integrated market. Same generator can sell the energy, regulation, reserve, reactive power, everything. Okay, before this unbundling, after the before the bundling. Okay, after this unbundling, it's all separate entity, so it is very easy. So which requires transparent service operated management market. Okay, transparent this operated market should be there. This ancillary service also should be transparent such that customers can know what is happening in the market. Okay, so such that they can understand the tariff easily. Okay, for this ancillary services they are charging this many price means, so they can understand, okay, based on this 24 hours this ancillary services they are maintaining operating for this many hours, so they are also operating in the back end model back end, so that also should be paid like that. The consumers can understand that thing easily. Next comes the emerging trends. Say, for example, if you take like hybrid and virtual synchronous generators, so inverters emulate this generator behavior. Okay, inverters also and also provide the synthetic inertia. So if you take like physical inertia synchronous generator, yes. Okay, so if you take like virtual synchronous generators, there is no. Okay, so if you take like synthetic inertia, synchronous generator, no synthetic inertia will be there. But in virtual synchronous generator, it provides the synthetic inertia is there. Okay, grid formatting. If you take a synchronous generator, yes, like virtual synchronous generator, also it is there available. So how the grid inertia, what is grid inertia, how it works means, grid inertia is nothing but is a system resistance to frequency changes. So provided by the kinetic energy of large rotating generators acting as a stabilizing buffer to slow down the frequency drops when supply suddenly falls or shortage of the demand. So buying time for a control system to react. However, the growth of inverter-based renewables such as solar and wind reduces this inertia. Okay, so which creates the stability challenges requiring new solution like synthetic inertia. Okay, from smart inverters to maintain the grid balance. So that is called synthetic inertia. So how this grid inertia works in the sense, when a power plant fails or demand surges, the frequency of the alternating current begins to drop. Okay, automatically the frequency will drop. So because of the large mechanical parts of the online generators are physically spinning at a grid frequency, their kinetic energy also instantly released to the system. So that is acting as a buffer. So this slows the rate of change of frequency. That means ROCOF. Okay, giving the grid operators and automated control system a few critical seconds to adjust the power levels before the blackout or equipment damage occurs. So this is how the grid inertia works. So now you understood what is synthetic inertia. Okay, synthetic inertia. Now comes to the revenue stacking. So synchronous generators can earn from the energy market regulation, reserves, and the reactives support and all. This and all we discussed in detail. What is the energy market regulation, reserves and all. Okay, so that's why I am no need to discuss much in detail. If you want to learn this, you can go back to our previous classes, so you can easily learn. Okay, so now what is the main benefit of this revenue stacking? So cost recovery is improved in this. Market efficiency is also higher. So generator viability also sustained. It will be there. So if you take like a storage integration, so energy storage system competes with the synchronous generators in regulation, load following. Load following already detailed, we discussed. Regulation also discussed. Next, spinning reserves also discussed. Okay, so this energy storage system competes with this synchronous generator in regulation, load following, and spinning reserve. But synchronous generator remains superior for inertia, fault current, and long duration support will be there for this storage integration compared with the energy storage system. Next, just a comparison between the synchronous generator versus the inverter based resources. So, if you take like inertia for synchronous generator, physically it is there. But if you take like inverter based resources, it is synthetic inertia is there. Already we discussed what is synthetic inertia. Next, if you take like a fault current for synchronous generator, it is high. If you take like for inverter based, it is very limited. Okay, next if we take like voltage control synchronous generator is strong. Okay, inverter based resource it is moderate. Okay, because the inverter based resource it is powered by the battery storage system. Next, black starter synchronous generator proven records are the black starter. But if you take like inverter based resource emerging, it is a black starter is emerging. Next, market role synchronous generator is playing as a core. If you take like inverter based resources, it is now only it is expanding. So these are the difference between the synchronous generators and as well as the inverter based resources in the restructured power market.